Welcome everybody to Wednesday of the last week of school. Today we're going to be talking about a topic that is near and dear to my heart. It is networking. And networking is oftentimes considered one of the hardest things you can do in computer science, and not without reason. It is a tricky topic to get right. And C++ in particular has no support for networking out of the box. Java has networking built into it. C++, you kind of got to use a third-party library to get networking done. And whether or not that's a good decision, I'll leave to the philosophers. I personally would like to see some sort of networking solution in the standard library because, the internet, it's a thing. It's been a thing for 20 some odd years now, popularly, and many years before that. And it would just be kind of nice if you could connect to something using the standard library. But, I'm not on the committee. So what we're going to go over today is how to use networking using the Boost library. So Boost is kind of like the major... so if the standard library is the major leagues, Boost is like the minor leagues. And it used to actually have a lot of things that... were implemented in it and then kind of got adopted into the major leagues. Boost is a collection of 100, 200 libraries, something like that. The one that we're going to use is their networking library. And so if I pull up on the server here, we're going to do a little networking using, let's see here, using Boost volley shipperty reference. And in order to get this going, I'll go ahead and delete their attributions on it because I've started modifying this enough that I'll just give them credit. This code is from Boost's documentation. Okay, there. So I am using Boost's Iostream implementation for networking, which allows us to communicate over the network just like you do with CIN or cout, or with an Iostream and an OFstream. If you guys remember that, like how to make a file, Iostream ends, file.txt. This creates a stream that you can then read from. Right? If we have a string S, we could read from the file into a string. We could do the same thing for our variable here named stream. We can just read from it, just like that. This is as easy as networking gets in C++. There's a little bit of boilerplate, a little bit of, you got to include a couple things here. You got to use a namespace there so you don't have these, I don't know why, this is what it would look like somebody thought that was a good idea. I don't know what to, I don't want to tell you, but somebody thought that was a good idea. Yeah, they love their verbosity, but this is really as simple as it gets for networking. We create a stream, and we connect to a host. We connect to a port number. It'll make the connection. You can check to see if a failure happened, just like how if we try CNing something, we could say if not CN, if an error occurred. It's as easy as it gets. Okay, almost as long as Chrono. Oh. Do not get me started on Chrono. Is this just connecting through LAN? No, this will work across the internet. We're using localhost as our server. Localhost means the server that we're on. But if I were to put, Google or something like here, www.google.com, this is going to try and connect to Google on port 2101. In fact, let's try connecting on port 80 and see what we get. So let's make this and run it. It's going to try connecting to Google and grab something from port 80, maybe nothing. I don't know. Maybe the connection's refused. I don't know. But that's as simple as it is. And so we're connecting to Google, port 80, and we're going to try reading in a string, and I don't know, they probably are rejecting us with good reasons. So you can type in any IP address there. You can type in 121.21.33.44, whatever IP address you want, and a port number, and it'll connect to it. Localhost, though, is always easy for I forgot. I forgot what port it was. Server.cc. I'm hard coding port 2101. I don't know why. Client.cc port 21. I almost had it. 2101. Like that. Okay. And so yeah, it's just it'll make a connection. Localhost just happens to be the machine you're on. But like if you have like a Linux box and a PC, you can have them talk to each other. It's pretty easy. It's you know, just kind of like how when you make a file, you have that extra one line of like, let's open up file.txt, right? You have that one extra line of like, let's open up a connection to Google on port, you know, 999 or whatever. And then you can just read from it and you can write from it just like this. This is going to read a word, a single string from the socket, and that's going to write a word back to the socket. And so you can check for an error by saying if not stream. So for example, if I compile this and run it right now, the server is not running. So the client will try connecting. Connection fails, prints an error message. Okay. But if I run the server, waiting for Godot, and let me duplicate the session here. And I run the client connects, and the server sends ping to the client prints ping, and then the client responds with pong, and then the server prints pong, and they just go back and forth ping-ponging one packet to each other 3 times per second. And I have it set up so that if any of them quit, like if I Control-C out of this, then the other one will quit as well. Because then client.cc, if an error ever occurs, like if the other side closes the connection, it just quits. So right now, this code is just an infinite loop. It reads one word, and then it writes back one word. And it's printing to the string. It's printing the string to the screen. It's printing to the screen the string that was read from the stream. Yeah. It's printing to the screen the string read from the stream. I said that right. Okay. So we get this from the internet, we print it to the string. Now we print it to the screen. The string goes to the screen from the stream, and then we write back to the. I'm not going to try and say it. We're going to send to the server a pong. What was the thing about seashells on the seashore, or something like that? Okay. So. We read one word. The word's always going to be ping. It could be anything, but we're going to read ping. And then we print ping, and then we write back pong. And then if we look at the server code, snap it over to the left, server.cc. And I'll give Boost credit for this as well. There you go. All right. I don't need you anymore. I don't care about daytime anymore. Okay. So there's a little bit more boilerplate on the server side. Maybe I can make this a little bit more meaningful. Waiting for a client to connect. And then I can print out client connected. Does anyone know the reference, waiting for Godot? It's what the Godot game engine was named after. Heard of the play? Here's a movie, Waiting for Godot. Read a string from a string stream to the screen. Nobody? Waiting for Godot, I think, is like an absurdist play where there's like 2 people just standing like at a bus stop or something, and they're just like constantly waiting for Godot to arrive, and Godot never arrives. It's just like an hour and a half of them just like talking, waiting any second now. Godot's gonna get here. So that was the reference. So all of this is just basically boilerplate. Stick it in there. The only thing that matters is the port number, which I'm just hard coding to 2101. You could, like the demo code that came from Boost, you could actually configure which port it came with. I'm just hard coding it. So is the 10-minute bus stop where the actors improvised the whole thing? something like that. And it's just very absurd. And they just, well, Godot's going to get here any minute now. Okay. So now it's going to print a more useful message. It's going to say we're waiting for the client to connect. All this stuff here is just to get to this point where we are going to wait for somebody to connect to the server. And it will pause. And then once the client connects, it'll print client connected. And if there was not an error, then it will go into an infinite loop. And so you might notice that there are parallels between these two loops here. In fact, they're going to look almost identical, but slightly different in a very important way. The client is doing a read, then it's doing a write. Look, the client over here is reading a word from the socket, and then it is sending a word to the socket. So it does a read of one word, then it does a write of one word. Then it does a read of one word, then it does a write of one word. And it keeps doing that until somebody Control-C's out. Until somebody breaks the connection, and then it quits. The server is the opposite, right? So the server starts off by writing first, then doing a read, right? So if I screwed this up and did it backwards, what do you think is going to happen? So if we have the server trying to read and the client trying to read, and they're both waiting on each other to send something, and they're both waiting, and they're blocked and waiting to read, what do you think is going to happen if you both have them read and then both have them write at the same time? Yeah, you got deadlock. So it's important that when you have, this is a very simple way of doing networking. Most multiplayer games have to do much more than this. This is like the hello world of networking, like making little ping pong thing where a guy gets something and you send it back, and they get something and they send it back. This is as simple as it gets. But even still, even in a simple situation like this, you can get deadlock. If both people try to read at the same time, they will wait forever for Godot to arrive, and Godot will never arrive. And so you have to be careful so that you have the server do a write then a read in a loop, and the client do a read and a write in a loop. And they're like backwards from each other, right? So one's doing a write and a read, the other one's doing a read and a write in an infinite loop, and they will just sit there and ping pong things back and forth between them forever. It's going to look kind of like this. Can't wait to take networking. Networking's fun. I like it. I like it a lot. And it gets way more complicated than this too. So here you've got, let's do a picture. And so we have the server over here, have the client over here. So the server is going to send to the client, ping, and the client's going to send back pong. I guess I don't need a box. We just do this, I guess. So the client's running and the server's running. So the server starts off by doing a write, and it's sending ping over here, and then the client will write back pong. And so the client does a read first, then it does a write, and the client does a write first, then it does a read, and then it does a write and a read and a read and a write. And so they go read, write, write, read, read, and then a write. Over and over again, infinite loop, read and a write, and a write, and a read. That makes sense? Symmetrical, one-to-one. Okay? It doesn't have to be one-to-one. It could be like 2-to-2. You could do like 2 writes on one side and 2 reads on the other side, and then they do 2 writes and you do 2 reads. Like, it doesn't have to be just one thing. One thing does make it simple to not deadlock, but the way that I actually usually code it is I usually send two packets. I usually send 2 messages. And what I usually send is like 101. I send like some sort of like control code. Like the client got Jeopardy right. And then that's like packet 1. And then packet 2 is like, it took 5.4 seconds. Right? I might send that in a string. I might send it in a float. Doesn't really matter. And then that's the thing. And so every time I send something between a client and a server, I will typically have a control code saying what kind of packet this is. The user is trying to log in. The user is trying to create a new password. The user is trying to submit a quiz answer. and then sometimes the data could just be empty, like disconnect. Okay, cool. I'm quitting. The data could just be empty. It could just, you just send control code 667, and then it'll just, the data doesn't matter. But it's a lot easier this way because, like, I was looking at some people's code in the previous class, and they were sending like one string because they were doing the one out and the one back and the one out, and so they're sending this really complicated string saying, I answered the Jeopardy question in 5.4 seconds. And then they were like parsing, they were like string streaming, like pulling words out and getting the number and then dropping the S and converting the 5.4 into a float. It's like, forget about it, Rather than all that nonsense, I would probably just send a control code saying, I answered the question on time. It took me 5.4 seconds. When it comes back, I parse that. I'm like, okay, we're still in Jeopardy. It's just, there's going to be just a giant if, else, if, else, if, else with all these control codes. There's just going to be tons of if else's or like switches if you want to be like switch person. You just have, the first packet's like which kind of packet we're getting, and then the data can get parsed differently depending on the control code. It makes your life a lot easier if you do that. And so would the data override if there is a collision? I don't know what you mean by a collision, but you can do something like this. You can say like stream, 101. And you want to use an inline, by the way. If you don't have an inline, it won't actually flush the data to the socket, and the client will just sit there and wait forever. So the new line here is actually real, not a new line, like an actual inline, because inline actually does a flush. It actually will kick that data out over the network. And so doing something like this, we can say 101, I don't know. Quiz answered successfully. I don't know. And then when we do a read, we can read like integer code equals 0. So we could like read in a code. So we can write out a code and a string, read in a code and a string. And then, like I said, based on the code, it could be something like they dropped the ball, they didn't answer it on time, or they're currently shooting a torpedo at us, or something like that. And you can write back, you could respond to the code saying it's a hit, or it's a miss, or it's out of bounds, something like that. It took you forever to Google to remember the /n doesn't flush. Yeah, it flushes on a console, like an interactive terminal like this. It'll actually flush, I think. Yeah. But on a file or a socket, it doesn't, which is a very minor difference in how cout and cin work versus files and networking that has caused me grief before, because my code would crash, and because I didn't have an inline in there, the code that I had echoed to the screen would appear if it was going to cout, but it would not appear if it was going to a file. It would vanish. And so there's just these little sharp edges that just get you sometimes. So this is kind of like how I would do it, right? So I'd do something like this. Like I'm going to send some sort of control code. 101 means quiz has been answered, and then I could write like success or something like that. Failure. I don't know. Make it a little more interesting. Rand modulus 2 question mark success or failure. So it'll randomly write back whether the quiz was successful or not. I don't know. I'm just making stuff up here. And then we're going to get back from the, who are we in right now? Who are we in? Control G. We're on the server right now. So we're going to start off by doing a write first, then we're going to do a read. And so we're going to do 2 reads and 2 writes. Like I said, control code, data payload, if there is anything. You can just send an empty string if you have to. Can I put this in public? Yes. It's already in public, actually. Not this version, but the one from the 12 o'clock session is in public. And then reading the code, and then reading a string, and then if there's an error, we break. Then we're going to print. and then it goes to sleep for a third of a second. The reads will block. The reads will sit there and wait forever. So you don't technically need to sleep like when you're doing your actual game, because it's probably going to be waiting for the player to enter a thing most of the time. But I have an infinite loop here, and I don't want to just spamming things forever, so I have it pausing like a third of a second at a time. These are in microseconds. Okay, so that's my server. Now, this is going to break, because right now my client is only doing one read and one write. Let's find out what happens if you if you have if you update your protocol, because this thing here is called a protocol, right? This is actually the hard part of doing networking, is that you have to come up with a protocol. You have to actually say, what gets transmitted when. That's actually the hard part of networking. The actual coding part isn't that bad, right? Because the coding part is just, this could be a cout, right? Like, you know how this works. If it was cout, it print 101 to the screen. This is going to go over the network to the client, right? Like, the coding part's not the hard part. The hard part is making sure that the two things are kind of symmetrical and mirror images, and they're not going to deadlock. And so, like, I'll typically have like a protocol, and I'll actually have this written down, right? And I'll be like, all right, the first time you connect, you get a 101, get a login packet, and then you get like 102 auth, or a 103 denied, in which case it'll go back to the, like, I have like every possible interaction between the client and the server has a type of packet. It's a login packet, it's a change your password packet, it's a disconnect packet. Each one of them has their own number associated with it, and then like the data. There we go. Okay. Data. And so there's going to be like some sort of code, and I have all these things written down. Like, if you look at, not in dim, am I? If you look at my actual code that I've written in real life, like, I've got all the different control codes. Like, somebody's creating a new account, they're giving me a new password, they're authorizing themselves, they're starting the quiz. This is actually for something somewhat similar, actually, to what you guys are doing, except I did it like for realsies, for actual money. If you took American history here in Fresno County between 2008 and 2015, there's a chance you actually were using my system to do multiple choice testing on American history. And so I had a client and a server, and I had a protocol set up between them, and they would send a control code saying, we're starting the quiz now. This was like, great. And then this, and then they send an answer in, and they go back and forth like this. And there's special admin accounts, and admins can force a reload of the passwords file if like passwords were changed or something and it wasn't updating. Like, I've like all these things down, and then these are like the different data packets that can like go out over the network as well. And so I have all of this like written down, and like I have a document that documents the whole process. Like, when they log in, they get this and this and this and this, and it's like a bunch of, if statements, basically. So, yeah. So let's see what happens if we run the server, and we run. Did we update the server? We didn't update the server. Okay, let's quit the server. Okay, so let's run the server that has the new protocol that's going to send two things, and then let's run the client that's running the old protocol, and you can see it quits immediately. Right? So it did something, and then it bailed. And this is actually something that's really important. When you have a system that has a protocol like that, you need to make sure that your protocol versions are the same. So there's a famous thing that happened where there was a stock market trading company, and they updated 9 out of their 10 servers with a new protocol, with a new way of talking to each other, but not the 10th one. And so when you're giving somebody a command to like buy stock, and the command to buy stock is, I don't know, 462, and that changes to be like sell stock instead, and you update it on 9 of the 10 machines, but you don't do it on the 10th one. As it turns out, it is possible to lose billions of dollars in 15 minutes. You start off the trading day, go to the water cooler, get some water, say hi to people, come back, your company's bankrupt. Wait, what? Yeah, we were buying Coke at 300 and selling it at 10. As fast as we could. We have no money. We just lost $10 billion in 15 minutes. All right, great job, everybody. Go home. You thought you had a job. You thought you were working for a big trading company, but nope, we're bankrupt now. Somebody screwed up on the IT update side of things. Programmers, you guys kind of screwed up too. You probably should have put a version number into your protocol so that when everybody starts talking to each other, you're like, hey, what version are you on? And you're like, I'm version 9. And they're like, I'm version 10. Like, oh, shoot, we can't talk to each other. They probably should have done that. They didn't. So, oopsie, we're now out of business. That was a fun 15 minutes. We just poured all of our company's money into a black hole and are now, bankrupt. So, bye. I guess start looking for jobs. Yeah. You're like the CEO and you're like having all these meetings. You go off to golf and meet with the head of Goldman Sachs or something. Hey boss, we're bankrupt now. What? Yeah, we had a bug in our code. We just gave away all of our money. Sorry. Bye. Yeah. So adding version number to your thing is good in real life. For this, probably not so much. Okay, so we need to update the client because you can see it's not working now, right? So we need to update the client, and the client needs to read 2 things. It needs to read a integer code, and so we'll read a code first, and then we'll read a data. Call this thing data now, and I should probably just use the code. Probably just use this code right here. So yeah, and so this client code and this server code are going to be really close to each other, right? Oh, except for that. Yeah, we need to update that one. All right, so we need to, I don't know, stream out code 102. I don't know, whatever. These shouldn't be just numbers, right? These should be like an enum or constants or worst case hashtag define something or other. But I'm just showing you, and then you're like, I don't know, like cool dude, I don't know, and that's it. So we're now, the server starts off by writing 2 things, the client starts off by reading 2 things. Do you see that symmetry? And then the client sends 2 things, and the server reads 2 things, and then they just go back and forth reading and writing to each other, ping pong, over and over again. Okay, perfectly balanced as all things should be. Okay, so let's build this and see if this works. Now, if you're making like a real server, you don't have one server and one client talking to each other like this. It gets more complicated than this. But this is the beginning. All right. Oh, yeah. It's only reading one word. It's only reading one word. We need to switch this out here with a get line, maybe a get line stream into data. Let's see if this works now. Nope. Almost. It's because mixing these things isn't a great idea. Let's go back to stream data, and I'm actually just going to edit the client to be okay. Just one word. Make it simple. Probably I should switch all those things to get lines, but when you mix and match double right arrow and get line, it breaks everything. It's one of the reasons why my read library is the superior choice. Okay, there we go. So now it's working. So you can see that the client here is printing out the code, and whether or not you got the question right or the question wrong, it's just making it up. It's flipping a coin. And then you can see the server on its end is getting an okay back from the client, and they're just going back and forth, back and forth, back and forth. Okay. Is this recorded? I sure hope so. Is my mic on? Yep. Recording is on. Yep. Okay, so I'm going to copy client.cc into /public, and I'm going to copy server.cc into /public, and I'm going to call the California Highway Patrol. Okay, so if you want to copy the code, it is going to be in public client.cc and server.cc. Okay, so I will put that up on Discord for you. So what else should we talk about with networking? Because this is kind of all you need to know for the networking section of Iostreams. Because basically, and I'm not going to downplay the difficulty, because you have to think about it's not coding hard, it is thinking hard. If that makes sense, right? Because from a coding perspective, you got all this boilerplate, ignore that, right? It's done for you, right? Just change the port, so you don't conflict with other people. But coding wise, you all understand what that means, right? It's just like couting 101 to the screen. You're couting it to the client, it's going through the interwebs over to the client, and then you can read in things from the network. Coding wise, this is no different from what you've been doing with CN and cout or file Iostreams, right? But from a thinking perspective, how do you tell somebody, okay, volleyball phase is over, battleship phase begins? I would create a control code for that. Okay, I dropped the ball, you get 3 shots now, right? And okay, battleship phase is over now. It's volleyball phase. And during battleship phase, you need to be able to say, I am shooting at you at location B7. And then you need to write back miss or hit, right? There need that back and forth. This thing, documenting that and designing your protocol, it's something you'll have to think about. It's something that will hurt your brain probably. But the actual technical part of it, is just literally, no different from what you could have done first or second week of school. There are other networking libraries for C++, most of which are much harder to use. C++ does not have a good... I don't want to say they're not good. I want to say they're not good for freshmen. Let's put it that way. The networking libraries are sort of targeted at people who are more experienced programmers. And so I actually, in the past, when I've done this assignment, I had them do Java Jeopardy, networked in Java. And it's actually easier for students to do the entire project in Java, a language they have basically no familiarity with. It's actually easier for them to write the assignment in Java, because it's so much easier to do networking in Java that it's faster to teach the entire Java language than it is to teach networking to people in C++. that's why I do it in Java most years, because that's how much easier networking is in Java than C++. It's a major difference. The Boost TCP Iostream library is the only thing that I found that actually is like reasonable for new programmers. I have gone through a lot of libraries that are supposed to be like easy to use. Like there's like ZMQ and I don't know what else. I've gone through a lot of like C++ networking libraries, and this is the only one where I like feel happy showing it to freshmen. So, networking part is 10 points. So if you get it all working on a single terminal, you'll still pass. Yeah, but I think you should do it, because if you do it, it's another 10 points. Because remember, everything stacks. If you do TDD and networking and Java and all the other bullet points, you will get 60 points out of 50. And so that is a substantial amount of EC, electric car. No, wait, extra credit. Boost seems pretty nice. Yeah, it's, I mean, like Boost as a whole, like, yeah, it's a cool project. And I like the fact that there is just some, decently high quality libraries. The downside to Boost is like a lot of the libraries compile really slowly, and so they'll actually like just really damage your compile times if you use them. And so I kind of wish like some things like Boost has split and trim, which are two things that should be in the standard library that aren't. But if you include them, it like adds a second and a half to your compile time. It's like, why? These are like simple like 5-line functions. Like it should not be slowing my compile time down so much. Split, yeah. Like every other language has a split and a trim in like the standard library. Like, okay, not C, fine. But you know what I mean? Like you have to use Boost to get them in C++, which is just, I don't know. It seems weird to me. If you can get Battleship working in single player, you should be able to get Battleship working in multiplayer, right? Just instead of sending, like at the very, like maybe the easiest way of doing it is just you just have all of the logic on the server, and all you send to the client is like, here's the Battleship board, what do you want? And then they enter B4 and then it sends that back. Like you probably could just make it all a single player game, and then you just have an option whether or not you print the Battleship, whether or not you print the text on the local machine, or if you send it to the remote machine, and the remote machine sends a string back that's the input. You probably could actually cobble together something where the client basically is like almost an empty file. It just displays the string from the server, and then it reads one, word from the, client and sends that back to the server. You can probably almost just hack it on top of the single player game. So have it print on both. You could. Battleship is kind of a dumb game if you can see your opponent's board. Like, where is their battleship? Oh, it's right there at B12. I guess I'll shoot it. So, but you could, you could do like the trivia, going to both people at the same time, and just see which one answers first during less time. Yeah, you could do that. That'd be fine. Yeah, but for Battleship, you definitely want to have each person have their own board. Yeah. All right. Yeah, imagine seeing the player. Yeah, single player Battleship is not a fun game, Betancourt. It's not. We've done that before. Like I don't know if you did the Battleship homework assignment in this class. We did do a single player Battleship game. It is not a game. It is they're the ships. Are you're gonna hit it or not? Close your eyes and type input. Yeah. You just have to have very bad short-term memory. Just look away as you're typing. Okay, so let me stop the recording here, and then we'll talk more about the project in a second recording.